Now, what happens when there are other repos pushed into origin, so the state of origin might change at any time? Now, we cannot just write changes to the remote, we also must read changes from the remote. Things get a bit more complicated here, so I will use a diagram here instead of a demo. Imagine that we have a remote repo that looks like this. It's a single commit. I will use different colors for the commits, and I will not draw trees and blobs. I will skip them because they would make this diagram too busy. When we clone this repo, we get the same objects in our local repo, and here are the branches. I'm assuming that the remote has the default name origin, so the remote main branch is called origin main. Now, let's say that we add one commit. And we push. If the remote's main branch hasn't changed in the meantime, then things are easy for Git. It copies our new commit and the associated object to the remote, and then updates the remote's main branch to point at the new commit. And it also reflects the change locally by updating the remote branch origin main, and everything is aligned again. This is what happened when we pushed our changes a few minutes ago. Now let's do it again. This is the initial situation again. We add a commit and we prepare to push. But this time imagine that something has changed on the remote as well. Someone pushed another commit to the remote, this green commit. Now we can't just push, we have a conflict here. We have two different histories that need to be reconciled. In this case we have two options basically. One option, which I would not recommend, except in very special cases, is to force a push. We can do that with git push -f, that stands for force. That's like saying, I don't care what changes are on the remote, forget about them, and just match my local history, that's the real one. So when we force a push, this happens. And we're probably losing that on origin. Here we are losing the green commit. No branch is pointing at that commit anymore, so it will be garbage collected eventually. We're also creating a very confusing situation for all other people synchronizing to the same remote, because now their local history will be conflicting with the history on origin. This is our teammate, Annie, working on the same cookbook repository, and she still has the old green commit in her repository. But after our force push, if Annie tries to interact with the remote, she'll have a conflict. Her history doesn't match the history on the remote, even though she didn't cause the conflict in the first place, so she'll probably be left wondering what happened and how to solve it. So forcing a push is not a good idea in general. It doesn't really solve conflicts, it just puts the burden on other users to solve a conflict. So it's not going to win us many friends in the team. But we have a second better option. Let's say that we didn't do that force push. Let's go back to the situation we had in the beginning. We added the light blue commit and we have a conflict because somebody else added the green commit on the remote. What we want to do in general is, we want to fix the conflict on our own machine before we push. To do that, we need first to fetch the data from the remote. There is a command to do that called git fetch. We get the new objects from the remote, and we also update the current position of the remote branches, origin main in this case. Now that we have the new commit and the related objects, we can merge our local changes with the remote changes. So we did the fetch, now we do a merge. Of course, during the merge we might have to fix merging conflicts and the like, but the important point here is that we are not rewriting history. Merges never do that, they just add the new objects. So once we do the merge, our history is the same history as the remote, plus our local stuff, the light blue commit in this case, and we can push that new stuff to the remote without rewriting the remote's history. This is what you do most of the time. You fetch the changes from the remote, you merge them into your own repo, and then you push the result. This sequence of a git fetch followed by a git merge is so common that there is one single command that does both. It's called, you guessed it, git pull. A fetch followed by a merge.